basically today what I plan to do for the next 20-25 minutes is talk about a couple of different things. First thing is just give you an overview of what we do in the analytics and applied sciences. That's the name of my organization. What we do at a high level, means what are things we are responsible for, and then go a little bit deeper into one or two use cases so that it gives you a flavor of what the team does and so on. Yeah? I don't think this is connected. Oh, is it? Okay, cool. Yeah, so just to see, the most important thing here to understand is, I think in any technology, it's easy to solve problems at a small scale. The challenge usually is how do you scale things, yeah? So just to give you a view on what is the scale, we have around, means I'm sure most of you are familiar with Flipkart, but just to give you some metrics, we have around 400 million, I think it's closer to 500 million now, registered users, about 150 million products, and we get around 2 billion monthly visits, which is essentially sort of the scale that we operate in. And we deliver to like pretty much most PIN codes in India. Yeah. So that's the scale. And the key thing about this is, at this scale, how do you build solutions that can help you drive decision? That's basically what I'm going to talk about. Sorry, I don't know. The clicker. Okay, sorry. Let me make sure this works. Yeah, cool. So, so what does the team do? What does this function do? I think this pretty much summarizes the key responsibilities. Yeah. So the first thing, which is what we call measurement science, is essentially leveraging statistic, machine learning, so on and so forth, to build sort of what is the objective. So every year as we start the year, one of the key things we do is we set targets for the company for everything, starting from customer experience, growth, transactions, customer metrics, supply chain metrics, so on and so forth. What are the targets? And these are typically built through hierarchical, statistical, and ML models, so that for every L0 metric, what does it mean at the next level, so that there is a structure by which different functions can do what they do with a very clear path towards meeting the L0 metric pretty predictably. For example, let us say maybe take NPS as a metric. Let's say we have a target for NPS. What does that mean? What drives NPS? So the first thing is we have a model which can predict NPS within a sort of a error of 1 every year, given a set of input parameters. For every week we do this, and then we build targets at the next level. So what should the speed be? What should the delivery efficiency be? What should the breach be? What should the and then so on. So hierarchically it goes down, so that at every team level you have a clear sort of target, so that they all add up to the target there. So there's a lot of science that goes into that. Then there are data assisted human decisions. It could be operation, strategy, planning, and strategy. It could be things like what are your key hypotheses, how do you test them, running ABs, running synthetic controls, so on and so forth, right? And then the last piece is machine learning and AI. What are the key machine decisions that we sort of take care of? Okay. Yeah. So the core of everything is the data platform. So there is obviously what we call FDP, or Flipkart Data Platform, which ingests data from every. So this, the first few years I was in Flipkart, this was pretty much what spent most of the time on, because there's not much you can do in analytics and data science without actually the data being there. So this is where we spent a lot of thing around structure, around data ingestion, making sure that every source engineering team ingests data into the platform and so on and so forth was the first thing. So just giving you an example of some of the data and some of the decisions that these data drive. I'll go into a little bit more detail into this. Okay. So the other key pieces for us, experimentation is a key part of the culture. We run around 50 launches every week. Each launch goes through an A/B experimentation. Sometimes you can't do an A/B experimentation. For example, if you are trying to understand impact of price elasticity and so on, because we don't, the sellers control the price. So then what you do is you try to do things like synthetic control, where you mathematically or statistically understand what the impact of different things are, where you can't, if it's a simple feature like a new home page or a new tab or something like that, then you do it through an A/B, simple A/B experimentation. And we do run multiple A/Bs, back testing, so on. There's a big science around that as well. And then there is a science around how do you do synthetic controls, right, where you can't run an A/B, how do you do that. And long-term experiments to assess impact. So you do what is called a reverse A/B, where there's a small population always on a holdout, and we have global holdouts, things like that. So there's a big, this A/B testing itself is a big science. And then real-time analytics and dashboards obviously is a key piece. Okay. Sorry. No, I think we went for, yeah, okay. So these are some broad areas where we work on, and like I said, there is a Flipkart data platform, which is the sort of the core for everything. And then there are multiple areas around building product insights, where what do you build, working with the various product teams, and sort of structuring experiments, making sure doing some of the pre-work on what features make sense, what features don't make sense, and then also how do you run the experiments, how do you evaluate, how do you drive decisions. Yeah, user insights again around, again this is, there is obviously an offline piece and a real-time machine learning piece on how user insights get leveraged, both in things like offline targeting and so on, but also on real-time, on discovery, personalization, things like that. Traffic insights, demand forecasting, and traffic insights for even engineering bandwidth and big events like big billion days, so on and so forth. Price value, here again providing seller insights to understand how they can drive growth through various pricing initiatives. Product assortment, selection. Selection is what I'm going to talk about, so we'll go deeper there. Supply chain, a lot of things on supply chain, speed, how do you drive speed, how do you drive network design, how do you drive sort of structures around different components of the supply chain, understanding where do you locate your hubs, where do you locate kiranas which can deliver for you, things of that nature. Yeah, seller insights have been growth, quality, experience, trust, and trust and safety. This is another area, because we have a two-sided platform, a seller and a customer, and we want to make sure none of them, means both of them operate with the highest level of integrity. Yeah. So now getting a little bit deeper, what we'll do is we'll go through one use case, and this use case will be mostly about driving assortment. Okay. Yeah, so if you think about what do e-commerce consumers want, I think you can broadly, these are the four big pieces, right? One is the pre-order experience, the ability to search, the ability to use the app to find really what you want very quickly, very efficiently. Then you want to make sure that the platform has the right assortment or selection. Selection is basically what retailers refer to as assortment, and you have the selection at the right price point for different customer cohorts. And then you have the right post-order experience. Once you order, things arrive on time and with the right quality and so on and so forth. And finally, the product quality itself. Yeah. So we'll talk about assortment, which will be those two pieces basically. Yeah, getting the assortment right. So here the problem statement is pretty straightforward. Assortment design, there are three components, right? You want to have the right width, depth and quality. What does width mean? Width means you have, see, as an e-commerce platform and particularly as a horizontal e-commerce platform, you sort of want to make sure that every category that consumers want to buy in e-commerce is available in your platform. That's width, right? It goes from things like fashion or grocery or electronics, mobiles, to all the way up to, in fact, I was talking to somebody from 𝗕𝗲𝗃, we were piloting having scooters in the e-commerce platform. That's width, having a variety width of selection across. Selection depth. So the next piece is selection depth, right? So for example, if you want to have a Nike basketball shoe on your platform, how many types of Nike basketball shoes are required for a consumer to feel that they have enough selection, right? That is the second piece. And also is, are we getting enough variety of designs? This is something I will talk about later, okay? Do you have enough variety? For example, if you are selling kurtis or shirts or saris or whatever, what is enough variety of designs, right? What is depth there? So that is the other piece we'll talk about. And last piece is selection quality. See, and this is a challenging problem. We'll talk about a little bit of that, because how do you know you have the right selection when a new seller comes on board or a new product is brought on board? How do you make sure the selection is good, good quality? Okay, got it. So let's start with selection width, very straightforward. So selection width is most, the selection you can divide as head and tail and torso. Head selection is the sort of the key where depth or variety becomes very important. So these are things that are available everywhere, but their depth means you should have enough variety within a kurti or within a shirt or so on. That's depth. Torso, on the other hand, tail and torso selection are what is the width or the variety of things you have in your platform beyond, not just within a single category, across different categories, across different. So how do you build for width in a scale? So everywhere here, right, the point you have to remember is you have 150 million products, you have 2 billion visits, so on and so forth. So anything that is built has to be systemically built rather than, this can't be done through any manual analysis, yeah. So we get around 80 million search queries in a week. So one of the things we do is we do a natural language processing to categorize the cluster of queries. Let us say there are 150K clusters, approximately 150 to 200K. So then we look at what are the poor performing search query clusters, right? And that is measured through a metric called CTR, click-through rate, which means that you saw an impression, but you didn't click through enough relative to other queries. So within, you look at search query clusters where the CTR or click-through rate is very poor. You know now that this is not something, so the consumers see it, but they don't like what they see, so they don't click through, which means there is either a discovery issue or you're not discovering the right selection, or this right selection is not available. You split that and then you send sort of these clusters in in what we call a seller insight portal. So these are recommendations saying, hey, this is a selection. So we have something called a seller affinity model. So now you have a bunch of clusters which are poor performing, which means selection here is not good enough. Then you sort of translate that into actual selection and look at which seller is likely to have this, or which seller it's closest to what they typically sell, and then provide this as seller insight to them in a portal. So this is how this is one of the tools for driving selection width. So now let's go to selection depth, okay, or variety. This is basically what we are saying is, do you have enough variety? There are multiple ways to look at depth. One way to look at depth, which I'm not going to talk about today, but we look at that as well, is that let's say you have a Nike basketball shoe. How many types of Nike basketball shoe should I have so that people feel like there are enough? So that's more, it's branded selection. So it's more saying if I have 15 styles, then people buy a lot more from me. Above 15, it doesn't matter whether I have 15, 20, 25, 30. But below 15, if I have only 5 styles, then people don't come to me for basketball shoes. So that's one way to think about it. The second way is, how do I keep getting, second thing, problem statement here is, how do I keep getting newer and newer styles, designs, so on and so forth into the platform. That's what I'm going to talk about now. Okay, cool. So first thing is, first problem here is that I talked about 150. So there are two problems here, like I said earlier. There is a discovery problem and there is whether you have the selection itself is a problem. So the first piece is to solve for the discovery problem in a targeted way. So the key thing here is how do you, when you get new selection, we get around in a month, I think around 1.52 million new products, right? When you get new selection, see, the first thing to remember is only 25% of your selection actually get discovered and only 10% of them get sold. And this is true of all horizontal large e-commerce platform. It's like there's a lot of selection. So two things you want to do. First thing is, see, and there is a logic around discovery. The logic around discovery is that as things sell more, as things people like them more, they are more sort of visible, are discovered better in the platform. However, the problem with this is when new selection is there, there's a cold start problem. So what do you do about cold start, right? That is one problem. So now there are three things. First is things that are selling well, they will get discovered. That's a very natural phenomena that gets discovered. Then there is a cold start, and cold start itself can be broken into two pieces. One is complete explore, like you randomly show something, there is some percentage allocated to that, but then there is some percentage allocated to, I want to do intelligent cold start. This is about how do you do intelligent cold start, right? How do you do cold start with, how do you, even before something gets sold or something even gets viewed, how do you sort of understand the potential of that listing? So that is the problem you are trying to do, and this gives an example of, so basically for that to happen, we have to build something algorithmically on what is a high potential listing. So we build a model. So this is a model which is built, it's a sort of a 𝗙𝗲𝗧𝗔 model, but basically there are a bunch of input signals. These could be product attributes, product images, and from that you extract out sort of image embeddings and so on and so forth, and do some more dimensionality reduction through PCA and so on. And the target variable here is what you are trying to optimize for. Yeah, is, sorry, okay, there's a delay here. Okay, good. So what you are trying to optimize for is both clickability and buyability, right? So the first thing is there is some heuristics around defining a score which measures whether something is a high potential or not, and then training a model so that based on a set of product attributes you can determine that score, right? So that is what this is trying to do, and this gives you an example of for various product categories, right? As your z-score, this is the predicted z-score, which is saying whether it's high potential or not, and based on the predicted z-score, particularly the higher z-scores, you see that these are products which are liked by the consumers. So this is one way. So here you're trying to solve the discovery problem given we are bringing in a lot of selection. So how do you drive? There is a complete random exploration, there is a targeted exploration, and then there is exploitation. Exploitation is things that have already been sold. How do you keep selling them more and more? The targeted exploration is what this is solving for. Okay, and now let's go to everybody's favorite topic, which is generative AI. So it's sort of become sort of everybody from Newsweek to Time, everybody's talking about generative AI. So I think we should at least spend a few minutes there. See, one of the things is, so what is the area itself? The area itself of generative AI has sort of exploded probably in the last 1.5 years, so on, while there have been a lot of development work for several years on generative AI. In a layman term, this is actually what AI was supposed to do in movies and so on and so forth. Basically, the ability to, for example, I'm sure everybody's heard of 𝗕𝗲𝗃𝗧𝗔, the ability to ask it a question and have a human-like interaction with the computer, or audio synthesis, having sort of real-time translation, things of that nature. I'm going to talk a little bit about the image synthesis. DALL-E 2 was a like 𝗕𝗲𝗃𝗧𝗔 was the image version. It can make dupe, means it's a sort of a spin on the famous artist Salvador Dali. So it's a spin on, basically you can convert a text to a painting. So you can ask it to paint things, or convert text to an image and so on and so forth. And I'm going to talk about another algorithm we use, which is a in fact more recent one called Stable Diffusion. And then there is video synthesis, producing hyper-personalized videos, so on and so forth, and 3D mesh synthesis, building from text prompt, building 3D objects. So this is an area that's developing. We still have to see what comes out and what is really practical and so on and so forth, but I'm sure a lot of VC money will go into this in the next 3-4 years. Some valid, but some probably, yeah, I think. So one of the things we are using this for, and we have found quite a bit of success with our sellers and for design, is what we call AI fashion designer. It's text to image generation, and the model constraint, the process is called stable diffusion. It's very similar to what DALL-E 2 does. But basically there is a forward process. So at the bottom you see a forward process where there's a process called forward diffusion, where you add a noise, Gaussian noise to the data, and you end up with pure noise. And then you, while the forward process, you learn the denoising process, and we learn the reverse denoising process in the forward diffusion. And then you create, because it's Gaussian, it's stochastic, you will create a new design derived from what the machine learned. Yeah. Yeah. So these were some of the designs that actually were built out of our AI fashion designer, and this is something what we have built, thousands of design. We send it to our sellers, they look at it, and we also suggest. So the process that works actually is like this. Yeah. So basically you auto-generate products that are fresh in our catalog. So the point is we constrain it to be fresh. So basically we give combinations of attributes that don't exist in our platform and ask it to design, okay. And so what the process itself does is, and then we use what I showed earlier, high potential to provide right visibility to the right product. So it's something like this, right, identifying combinations that don't exist in our catalog, right, and then doing this, the process I showed you, right, generate a product image that adheres to this set of attributes that are not available. So it's going to give you a fresh design, and so you got new design, but you don't know whether this new design is any good or not. Then we go to the earlier model I showed you, which is a high potential predictor. And then you add attributes like price, and then you add other attributes of the image, and then get a hypo score, which is the z-score that I talked about. And if you think it goes above, it's above a threshold, we say it's a valid design, and then we say, give it to the seller, and the seller can choose to design it and put it in the our platform. So this is something we have now started testing very actively with our seller base. Oh, it looks like if I do this, it works. Yeah. The last piece, quality. And I'll tell you what the problem is here. So the first thing, this is not a big surprise. Better quality leads to better NPS. I don't think anybody will be surprised by this. But what are the challenges? Okay. Can you do manual checks to all our products? No, because I told you it's 150 million products, and every month you're getting 1.5 million products. It's not possible to sort of manually, through human intervention, make sure everything is good, not scalable, basically. Can you use past performance, right? You know product rating, so on and so forth. Can you? That's a partial solution. That's not really something that will work. Again, because I told you, right, only 10% of our selections sell, and even in that, a very small fraction is where you get product ratings and things like that. It's not like everybody gives, means all of you buy from e-commerce, I'm sure, and it's not like every time you give a product rating. So the data is very sparse. So where it is there, it is probably a very good source of, if you have like 50 product ratings or above, or 20, 30 plus product ratings, based on that you can make a very good evaluation of whether a product is good or not. But the point is that that is available probably for 1% or 2% of our listings, not more. It's not available for 100%. So what do you do, right? So there is basically a cold start problem. It's the same as what I said about high potential. There's a cold start problem, okay? So we build something called a listing quality score. For every SKU that comes to the platform, we build something called a listing quality score. So how do you build it, right? And if you are able to build this based on a comprehensive set of input signals, then this listing quality score is fed into our discovery algorithm, and so make sure that the listings of poor quality never get discovered. And eventually they will get delisted, because if they never get discovered, they are never going to get sold, they are never going to get seen, and sellers don't have any incentive to keep putting them in. So what is listing score, quality score? It's there are two components. One is a product quality score and a seller quality score. I won't talk so much about seller quality score, because if a seller has been in our platform for a while, you kind of, the real problem to solve is product quality. And product quality is usually a function of what rating index, which is how do customers rate it, and returns. These are the two big signals. The problem is it's a cold start problem, because if you haven't sold anything, you neither have ratings nor do you have returns, right? So you don't know whether it's good or bad. So how do you solve this? This is the problem you need to solve. So this is essentially what we do. There is a machine learning framework where you have a bunch of product attributes. You know various product attributes, what brand, what material size, so on and so forth. Then you have seller attributes. You know how that seller has performed in the past as well, right? The product may be new, but the seller may not be new, right? And then you have listing attributes, which is essentially about the listing itself, the quality of image, what does it say in the catalog, the listing price, there are a bunch of things like that. And then sometimes you have ratings data for that. But in many cases, like we talked, there's a cold start problem. So you don't have returns and ratings data. So you start aggregating up returns and rating for that seller, for that vertical, for groups of products which are very, very similar to that, so on and so forth. And then put all this and you build a ML model that tries to predict both the ratings and the returns for a new listing. And then you use this to essentially calculate the listing quality score, and then this listing quality score is given discovery. So this was my last use case. So what I want to leave you with is, so obviously there are many things like that. So hopefully what I wanted to leave you with was you get a flavor of what analytics and applied sciences is able to do in e-commerce, and you can look at some of this and look at what data you get and what are the kind of problems you are trying to solve, and maybe it will help you think through some of that as well. Thank you very much. Do we have time for?
Yeah, we have time for a few questions. Maybe if you can raise your hand, I'll pass around the mics.
Hi, my name is Prabhu, and I work in healthcare IT. Again, we use a lot of NLP to solve the problem of healthcare. So the question which I had about the rating part, and you mentioned that you are going to use basically what kind of seller it is, what kind of product attributes are there. So to me, it looks like instead of solving using the actual data, what you have done, you have used the different kind of data sets, related data sets. So again, it's what was the basically unique thing which I couldn't get that part actually.
No, there are no ratings, right? It's a cold start problem.
Correct.
Okay, so you don't have ratings. So now
you used the basically similar kind of whatever the previous ratings was there, use that one to predict for the new product.
Not what ratings were there, that is only part of the things, but actually getting an understanding. Yeah, obviously it is trained on historical ratings, but the point is, it is what are the attributes of the product, what kind of product it is, so on and so forth, what kind of catalog it is. So finally, if you are able to understand how historically the seller has done, how historically similar products have done, what is the quality of the catalog, what is the quality of the image, what is the quality of all of these things, you will have a fairly good prediction of a listing quality.
So that was my follow-up question. How do you figure it out, all those 3 data blocks actually? Because that's another interesting problem to solve, right?
You have all the data, right? The catalog is uploaded by the seller, so you have all the catalog attributes. The image is uploaded by the seller, so you have all the image attributes. So in a listing, you have all of that. Then you have historically, hierarchically, you can go up, right? So you have a product, and related to the product, you have what we call a market SKU, which is it's a similar price point, very similar attributes. You have other products. You have data from those things. Then you have information about the history of the seller. So all of these are available to us to make these predictions. Thank you.
I would like to just understand that how you have been taking care of the data in a decentralized form, or you are centralizing and doing the analytics on the centralized data?
Sorry, so structurally, this is what it looks like, right? There are engineering teams or product teams across there are for marketplace, for sellers, for discovery, search, for supply chain, everything. There are different product and engineering teams, but there is a central data platform engineering team. So what we mandate are some guardrails and guidelines around how data ingestion should happen, and into the FDP, Flipkart Data Platform, and the data itself exists in the Flipkart Data Platform.
So the collation of data is pouring into a central repository of
Yes.
all the SKUs,
Yes.
and all
Yes.
on basis on which you are doing
Yes.
your analytics.
Yes.
Thank you.
Hello.
Thank you, everybody. We can,
sorry.
yeah.
I have just one question.
Yeah.
The pricing model,
Yes.
how do you define the pricing model, especially for the new listings versus the existing, depending on the demand?
No. It's not depending on that demand, right? Because that is a new listing. We don't have any demand. And two points, right? We don't do any pricing. We only suggest pricing to the seller. The seller is the one who prices. So what we do are what we call price recommendations to the seller. The way that works is essentially, again, you have the product attributes. And based on the product attributes and based on other seller attributes and things like that, because that seller may have other products as well, you understand broadly the price point at which that product can operate, and you suggest the price based on comparables in the platform itself.
So that's a competitive analysis being bring outside?
Yeah. We do a lot of competitive analysis. We sort of do crawls and do competitive analysis on other e-commerce platforms and so on and so forth. And that's part of what goes into price recommendation. Cool. Thank you. Thank you very much. I'll be around. Thanks.